Welcome to the AI Research Roundup. I am Alex. Today, from the Papers with Code trending list, we have Alita, Generalist Agent Enabling Scalable Agentic Reasoning with Minimal Predefinition and Maximal Self-Evolution, published May 26, 2025. This paper introduces Alita, a new type of generalist AI agent. It's designed for powerful agentic reasoning. That's the ability to think and act to solve complex tasks, but with a core philosophy of simplicity and self-improvement. Alita aims to be more adaptable than current agents by using very few predefined tools, instead learning to create its own solutions using what are called model context protocols, which are like custom instruction sets it builds on the fly. The authors report some impressive results, which we'll get into. So, this idea of Alita creating its own solutions on the fly using these model context protocols is really central to its design. And if you want to dive deeper into how all this works, well, the authors have set up a public repository for Alita. Right now, you'll find a really detailed README file, packed with more insights and ongoing discussions about the implementation. They've also mentioned they plan to release the full code for this work there soon, so that's something to keep an eye on. And speaking of results, this first figure really drives home Alita's performance. It shows how Alita, represented by the black bars, stacks up against other agents like Manus AI and OpenAI Deep Research on the GAIA benchmark. Now, GAIA is a tough test with real-world scenario questions. The scores here reflect pass-at-3 accuracy, meaning the percentage of times the agent found the correct answer within 3 attempts. Alita consistently leads across different difficulty levels, level 1, 2, and 3, and achieves that top average score of 87.3%. This really highlights that self-evolution capability we were just discussing. Alright, so this next diagram really lays out the core philosophy difference. Traditional generalist agents, depicted at the top, often come packed with many specific, manually engineered tools, like a URL text extractor or an image captioner. The issue, as the paper points out, is this large-scale manual engineering can lead to incomplete coverage of tasks and limited creativity. Alita, shown below, champions minimal predefinition and maximal self-evolution. It uses its manager agent and web agent to dynamically create what it calls model context protocols. These are those self-generated tools or capabilities, building them up in an MCP box. This design promotes more scalable dynamic capability and enhanced creativity. Okay, so building on that idea of the manager agent and web agent working together, this figure shows us the architecture of Alita, and specifically how it uses an iterative process called a code react loop for this creative synthesis. When a question comes in, the manager agent starts this loop. It first triggers what's called MCP brainstorming, which is where it figures out what capabilities are missing. Then, it moves into open source searching, script generating, and virtual environment execution to actually build those task-related functions. If a function is useful, it gets encapsulated, or packaged up, into a reusable model context protocol and stored in that MCP box we saw earlier, enabling Alita to self-evolve. That code react loop and the dynamic creation of model context protocols really are the engine behind Alita's impressive ability to grow and adapt. The key takeaway for me is this shift towards minimal predefinition, allowing for maximal self-evolution. This approach is so important because it points towards building more scalable and genuinely creative generalist AI agents that aren't limited by manually engineered tools. Well, that's all for this episode of the AI Research Roundup. Thanks for tuning in. I'm Alex.